The mole, Avogadro's number. Okay, so the number. Our number for the mole is 6.02 times 10 to the 23rd power. Okay, which means we're moving our decimal point 23 places to the right. Okay, so if we write this out, 602. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Comma, 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 comma. That is our number. I want you guys to put that on your paper. Okay? So this is how many atoms make up 1 mole. Doesn't matter if we're talking about 1 mole of oxygen gas, 1 mole of water. So we'd have that many water molecules. That is what 1 mole is. Molar mass. The mass of 1 mole of any pure substance. Okay? So when we have this many atoms of water, it's how much that weighs. When we have this many, let's just say, atoms of gold, it's how much 1 mole would weigh. Now, gold is a lot heavier, so we'll have a higher molar mass. Okay? Molar mass of an element equals the atomic mass of the elements in grams. Okay? Always in grams per mole. Okay? If we're doing molar mass equals the sum of the molar masses of the elements making up that compound. Okay? So for example, this is like water. This would be like gold, Au. Okay? These you'd find in the front of your periodic table. These are our compounds like sodium chloride, anything that we put together. Okay? Equals the sum of the molar masses of the elements making up the compound. Okay? So let's do a few different example problems. We'll do them right down here. Find the molar mass of magnesium chloride. Okay? Magnesium chloride. Right now, first thing you have to figure out, are we talking about an element or are we talking about a compound? Magnesium and chlorine, we're talking about a compound. You will need your periodic table. Pull it out now if you do not have it. Okay? So first thing you have to do is actually figure out what your formula is. Magnesium chloride. We have Mg. Our charge is +2. A chlorine is a charge of -1. Okay, so we need 2 negatives to balance out our +2. MgCl2. Okay? So now we need the molar mass of this. Okay? 1 magnesium, if we take a look, comes out to, on your periodic table, 24.3. And same thing, we're going to stick to 1 decimal point. 24.3. Now chlorine, looking at our periodic table, chlorine comes out to 35.5. It's 4, but remember the 35.45, that rounds up to 35.5. We're going to add this to, because there are 2 of them, 35.5. So let's figure out what our molar mass of this is. 24.3 plus 2 times 35.5 equals 95.3. Now, the important part here is using the correct units. Okay? We have a molar mass of a compound. This is always going to be, this is how many grams make up 1 mole. 95.3 grams per mole. That's what we're talking about. Okay? And our abbreviation for mole is MOL. So if we weighed out, if I asked you guys that we needed 2 grams, if we needed 2 moles of magnesium chloride, we would need almost 200 grams. That's what that would be. Okay? All right, let's do another one. Let's do aluminum oxide. Okay? Our charge for aluminum is +3. Our charge for oxygen is -2, and we got to balance these guys out. Okay, right there. Charges of +6, charge of -6 are now balanced. For aluminums, I want 1, 2. I want 2 aluminums. Oxide, I want 3. Al2O3. First thing you have to do is figure out what aluminum oxide actually is. Okay, and then we're going back to our periodic table. Aluminum, 26.98. That is going to round up to 27.0. And there are 2 of them. So we have that, parentheses 2, okay, multiply it by 2. And we're going to add to our oxygen. Oxygen we know is 16.0. And we're going to multiply that by 3 of them. Let's plug it all in. Okay, 27 times 2 plus 16 times 3. Okay, and we get 102 point nothing. 1 decimal point. Our answer for this is 102.0 grams per mole. All right, let's try number 2. How many moles of atoms are there in 8 grams of Mg? Okay, now we have 8 grams of magnesium. We want to know how many moles is that. How many of these is that? How many atoms are in 8 grams? So it's a counting thing. We're taking the weight of something, and we're asking ourselves how many atoms make it up. And remember, a mole always equals this number of atoms. Okay? So let's take a look here. So anytime we have a problem, you're always going to start with what they give you. We have 8 grams, okay, of Mg. Make your box. As always, we will need whatever we have down here to cancel out. Okay? It's asking for how many moles. We know that's what we want our answer in. Okay? So we know this has to be in grams of Mg. We know this needs to be 1 mole. Okay? And now we just need to fill our number in here. 1 mole of magnesium, we're going to find this on the periodic table. Okay? So we take a look for Mg, 24.3. Okay? If we had 6.02 times 10 to the 23 atoms, it weighs 24.3 grams for every 1 mole. Okay? That's what goes down here, 24.3 grams. If we're starting with 8 grams, we're going to divide it by this. This is less than a gram. If we weighed out exactly 24.3, that would get us 1 mole. Okay? Now, as always, cancel out your units. We're now going to take 8 divided by 24.3, and we're left with 0.329. Okay? For these answers, let's go to 3 sig figs. That's going to be our rule. Okay? So we'll have 0.329, and we're left with moles. Everything else canceled out. 8 grams is only 0.329 moles. It's not an entire mole. It's about 1/3 of a mole. Okay? So it's like taking this number, dividing it by 3. That's how many atoms you would have. Let's look at number 3. How many atoms are in 0.7 grams of He? Okay? So, kind of need our what we did in the notebook from last time. But same thing. We're going to start 0.7 grams of He. 0.7 grams of helium. Okay? We're going to do the same first step. We want to know what 1 mole of He weighs in grams. Okay? If we look at our periodic table, 1 mole of helium would be 4.003, or 4.0. Okay? Now, if we stop here, this is going to tell us how many moles we have. Okay? And we can do that. 0.7 divided by 4 equals, this is the same as 0.175 moles. That's how many moles we have. The next step we want to do is how many atoms is that? Okay? All we do, we take our next step and we multiply by this number, because each 1 mole is 6.02 times 10 to the 23rd. Okay? So after this, make another box. 1 mole of anything will always be 6.02 times 10 to the 23rd. Okay, so we have that number, which is 0.175, and I'm going to clear that actually. 6.02 times 10, raise it to the 23rd, multiply that out, and I can't find it on the calculator. I'm going to go through this old-fashioned way. 1, 2, 3, 1, 2, 3, 1. Okay, so we get this number in the calculator. I did not find the exponent. We'll find in a little bit. Okay, and oh, there it is. 6.02 times 10 to the 23rd. Nope, that's not right. We'll have to do this last one together in class because I cannot find my exponent button.